Hope I'm not the only one who feels like the preparation was a lot of matrices and the quiz has no matrices. Unless I didn't look at it the right way.
I'm sorry, did you say something?
Oh no, I'm just ranting about that the preparation activity had a lot of matrices in it, but the quiz doesn't look like it has any.
The individual quiz didn't have any.
Huh?
The individual quiz didn't have any either.
I liked that section.
Yeah, it was like super easy.
Right? Okay. Well, I guess we can go ahead and have prayer and then go through some of this.
Okay. I can go ahead and say that.
Okay.
Dear Heavenly Father, we thank Thee for this beautiful day that we have, and we thank Thee for this opportunity to study pre-calculus and progress further toward the finish of this course. And we ask Thee to bless us with Thy Spirit, and we say these things in the name of Jesus Christ. Amen.
Amen. Awesome. So let's see, where's the group hangouts? Okay, so going over question number 4. Wait. Begin by going over question number 4 and number 5. Ensure that each team member can find the sides of a matrix, add, subtract multiple matrices, and scalar multiplication. I mean, I personally thought those were like the easiest thing we've done all semester.
Oh yeah, same.
I mean, I guess, it's like how to add and subtract. I mean, you just take each value. If they're not the same size, you can't really do anything with them.
Mm-hmm.
And then if it's got the scalar multiplication, like you do its prefix with the matrices and then you multiply them. Yeah, I didn't have any problem with that section. I wish the quiz had those on there.
I think that whole section took me like half an hour to do.
Yeah, like I was going through the homework and I was like, oh, 10 questions, they must be super hard.
Yeah, nope. That's what I thought too.
They were fine. So I'm totally fine with the prep and the stuff.
Yeah.
The only thing I had with the earlier ones is that some of those take up like a whole page of work to do.
Oh yeah, the fractions or whatever.
Yeah, like especially when you get to like the A and the B and stuff. That oh my gosh. Let me see. Okay. Answer from question 6. Those are answers from question. It says discuss your answers from question 6. I'm not sure there was a question 6 on the prep work.
Yes. Oh, I'm on the wrong Google Hangout instruction.
Let me see if I'm on the right one.
Yeah, it says begin by going over question 4, 5, and then the next part says discuss answers from question 6.
Wait a minute.
Yeah, well, maybe that's a typo, or I mean, I'm not seeing a 6, so just pretend that it.
Oh, that's weird.
Whatever it was, we probably understood it.
There we go.
Let's see. Have one or two team members teach how they answered question 3. Discuss the process used to find the partial fraction decomposition. Courses. I felt that these were a little easier with multiplying it by the denominator. I started having more issue when it starts getting into the A and B, and you have to kind of solve for them in other ways. That I'm still a little kind of iffy on. But for the preparation activities, I felt that multiplying it by the denominator and simplifying what was pretty straightforward.
Mm-hmm. Yeah, I agree.
Because I mean, you multiply them, so then you'll factor whatever the top part is into it. Yeah, and then you simplify like terms, keep it over the denominator. Do you know if there's a preference? Because I felt like in the answers to some of them, like some of the homework as well, sometimes it wanted the denominator factored, and sometimes it didn't factor them. Is there a preference?
I don't know.
I can't remember. I know I had like a similar question that I asked somebody. And I think it might have something to do with the power of the, like the highest power, where the highest power is in the equation. Like for example, like if there's an x with a higher power in the denominator, I think you have to factor it out.
Okay. Like instead of having like the x plus 2, x minus 1, factor that out into x squared. And
I think so, yeah. I'm not 100% sure on that, but
I can see where that's coming from, though. I mean, higher. Yeah, because I couldn't figure it out with the assignments, because sometimes it kept them as like the binomials, or other times, yeah, it had them factored. So, but maybe that is something that I need to look at the powers of the x.
Maybe, I'm not sure.
Okay, but yeah, other than that, did anyone else have any other questions or anything about the activities?
I'm good.
I don't think so.
Let's start on a few of the extension problems.
Okay, yeah, let's at least do a couple, make sure we can work through them, and then the group quiz, I'll admit, looks a little intimidating, but we'll figure it.
Oh boy.
Yeah, I don't even know what half of that is on there, so yeah.
This should be interesting. It's a bit of a longer quiz too.
Yeah, it is, and that's where I'm kind of dreading that. Well, okay, well, let's at least do the first couple.
Okay.
On the extension, because yeah, I don't even see any of these on the group quiz either. Like, throw us a bone, give us something easy. Let's not look at that. I feel like these fractions aren't that difficult. They're just tedious. And if you mess up one part, then everything's messed up.
Yeah.
Okay. Shoo, shoo, shoo. I think I've almost got something. Okay. Done with that first one.
What'd you get for your 3 equations? Just to make sure I'm solving it right.
Okay, so for the first one, I got, for my 8, I got 2. So that'd be 2 over x plus 1.
I mean,
Oh, for your 1, 2, 3, those equations?
Yeah.
Oh, the first one I got a plus c equals -1.
Mm-hmm.
Negative 2a plus b plus 2c equals -9. And then minus 3a minus 3b plus c equals -12.
Okay, that's exactly what I have.
Okay, sweet. Yeah, see, I did one of these and I got outrageous, like on one of my practice ones, I got like outrageous numbers. I got like 600 and I don't know what I did wrong. See, I feel like we're killing trees every time we do this because, like, one problem is whole page.
Yeah.
Exactly.
I just have pages of it, you know?
And I really ask myself, when the heck am I ever going to use this in real life?
Right? Golly. Are any of y'all registered or going for the next calculus?
I will be.
I don't know what the heck I'm doing right now.
Yeah, I apparently I got an email from my calculus teacher, and there's pre-work to do for the course, and there's like a calculus boot camp you're suggested to do so that you're prepared before the class even begins. So
I wonder why.
oh man, it looks like a lot of stuff.
I don't know. I'm off next semester, so.
Same. I'll be taking calculus in the fall.
And lucky, I'm going through my. Well, I guess it's my on track. It's my husband's off track, but we're just working through all of it just to get done faster.
Yeah.
Oh man.
What was your final answer for question 1?
So I got A equals 2, B equals 1, and C equals -3.
Okay, that's what I got.
Yeah.
Awesome. Yeah, I feel like they're kind of straightforward. It's just you got to be super careful with your like terms and everything. That's really what you got to watch.
Yeah.
You just can't mess up.
Yeah. And it says like question 1 represents the second type of PFD. When a factor is repeated, such as x plus 1 squared, you have to represent each power of the linear factor in the decomposition. If the denominator had a linear factor of x plus 5 cubed, how many fractions would you have? So would that be full? Wait, is it saying if that was like also in the denominator? X plus 5 cubed, so you would need like a D, right?
Yeah.
Over x plus 5 cubed.
Yeah, I'm pretty sure.
Yeah, and then I think working that out, you'd all, instead of having the 3 equations to kind of work with, I guess you'd have 4, because then you'd have something that would be equivalent to the cube, and then to the squared, regular, and then so on. Well, I know it's already getting late for some of you guys, and I know we started late because of me. Do y'all want to go ahead and take a look at the group quiz?
Yeah.
Let's do that.
Okay. Given the system of equations,
Yeah. So determine what type of graph each equation represents. I worked out the first one. The first one is linear. So I have the first one is linear and the second one is quadratic. I don't know if Danny, y'all work those out.
I haven't yet.
Not yet. No.
I'm not even sure. Is that what it's even asking?
Determine what type of graph each equation. That first part definitely is that.
Okay.
But how do you see that the first one is linear?
So the first one, oops, hold on. I gotta put it on my screen or I can't see. So I have the x minus 4. So I subtracted the x minus 4 because then would have the y minus 2 squared, 9 minus y minus this one squared. And you can take the square root of that because then that would give you y minus 2. And then you can square root the 9 into 3 and remove the square root there. And then I just factored them out to get.
Okay, that makes sense.
So I think you can do that.
Pretty sure, yeah. And then that second one is obviously quadratic because of.
Yeah, I went ahead and factored that one out just because.
Okay, list the number of possible solutions when given the two function types you listed in part A.
List the number of possible solutions. So would it be? I mean, I guess you could have none because it could be like not even touching.
Oh, I understand now. Okay.
Is that what it is? I hated these when we worked through them.
So it says support your answers with sketches in that next thing, next part of the problem. So I think what it's asking is going to look something. Okay. So we have. Would you show me? So you factored out both of those two.
Yeah.
Could you show me really quick what the end result were?
Sure. For the top one.
First one is y equals negative x plus 9, and then the second one is y equals negative x squared.
Oh yeah, that's supposed to be minus 11. I messed up there.
Okay, so the first one is going to be
Wait, what was that second one again?
I'll hold it up.
so the line is going to be essentially something like that. And then this quadratic one.
Okay.
Remind me how you graph. Do any of you remember how to graph the that second one?
I'm gonna plug it in my calculator.
Smart.
Wait, it says we can use a calculator, right?
Yeah.
Yeah. Then we're good.
We can even use the textbook on this.
Oh, that's sweet. I'm gonna kind of miss that, having an in-person class. Oh, that one's odd. So it looks like that.
Okay. Okay. So it's gonna be x. Where does it say like what its vertex is?
What it's what?
Vertex.
I
Let me.
got the vertex of 4, 5.
That's sweet. Yep. 4. Y is 5. Wait. Yeah.
Yeah, x is 4, y is 5.
X is 4, 1, 2. Okay. Oh, gotcha. Okay. So it's gonna look.
Oh, well, sorry, real quick, going back to or B and C, B was like list the number of possible solutions when given the two function types. So I think that one's not necessarily asking for like the specific ones we have, but they're just like when you have a linear and a quadratic, what are the possible solutions?
Okay, so this is like really rough, but it's gonna probably look something like that. Maybe.
Oh, okay.
And so,
Is it possible for them to have like one solution?
let me. It says. Yeah, let me 1 second. So
Give me a second. I have to check on my baby. Yep.
you said the vertex was 4, 5.
Yeah.
Yeah. So wait. Oh, wait 1 second. Yeah. Oh, yeah. Okay. Okay. So here we have. So I know this graph is somewhat accurate and that the vertex rests one. The vertex essentially is one of the points in this line, because plugging in what you said was the vertex 4, 5 into both of these equations equal out to each other. And for this first part, that just means that the point 4, 5 is one of the points in the line.
Mm-hmm.
And then plugging it into the quadratic means that that vertex that we know is one of the points also.
Like one of the solutions.
Okay.
Does that make sense? And so the vertex, being the point that is in the solution, is going to rest on the line, which means there's one solution.
Okay, so is it that it is just one solution then?
Yeah,
Mhm.
pretty sure.
Yeah, because I sketched out, like, I guess the like when it was like the possible solutions, because you can have a quadratic and a linear that don't even touch, so there's none, or it could have two, or kind of like what we had, one. So then I guess this is the solution that we have, is the one. Okay, well, that's cool. I don't think I've seen one that only had one solution yet. Look at us, we're not doing so bad. Okay, well, now solve the system of equations.
Uh-oh.
So who remembers how to do that?
Do we just, since both of them are equal to y, can we make them equal to each other?
Oh, you're
then-
right. Solve for x and then plug it back in for y.
I guess. We'll see.
That sounds great.
Oh, okay.
Wait a minute, does that not work? Oh, does this make a crazy thing?
Does this make sense? This is, I'm just wondering if what I did was accurate, but so I set them equal to each other.
Oh,
And then I
There-
just moved it all to one side, and then I factored it.
there you go.
So that seems valid? Okay.
Yeah, that's exactly, I think. How do we prove that, like, that's the one solution? Like, how do we know that based on the it only gives one solution? Is it just because that's all it gives?
I think so. Maybe.
Well, I mean, it should just be based on the graph,
Yeah.
and it only hits at one point, so it would only give us one solution.
Okay, yeah, and I think that's more than enough to answer the problem. So yeah, so we determined each type, we list the number of solutions, we sketched out the possible solutions, we solved it, and this one has one solution, and we verified it with the graph and calculator. Pretty good.
Okay, number 2.
No, number 2. Well, I guess number 2 is better than number 3.
I don't even know where to start with number 3. Okay, when Sarah and John work together, they can move their handcart 3 miles in 5 hours. Sarah takes 1.5 hours longer to move the handcart the same direction, or the same distance when she is working alone than it takes John. How long does it take John to move the handcart 3 miles when doing it himself? Hint, it will take him longer than when he works with Sarah.
How about it doesn't matter how fast as long as they're both going towards Zion?
True. But I don't think that's what they want.
Let's see. So would we make them both variables and like maybe both equations?
That's kind of what I'm thinking. So they move their handcart 3 miles in 5 hours. How would we note that? 3 miles in 5 hours takes 1.5 hours longer.
Yeah, because I was gonna do like S plus J equals 5, but yeah, how do you do the 3 miles in this amount of time? Would we make those into fractions?
Is this number 2?
Yeah.
Oh,
Yeah, I was trying to work on that earlier, and I just could not figure out how to set it up, or the equations.
Let me try something.
I tried putting them into fractions as well. Try to like get miles per hour just as one variable.
yeah. See, that's what I'm thinking, because I mean, speed is time over distance, so I mean that's not a bad measurement.
Yeah.
No, that doesn't work.
How long does it take John to move the hand cart? 3 miles. John equals 3. Or would it be something where the time isn't necessary? Well, never mind. Or maybe, or the time isn't necessarily the thing. Because like, couldn't you do like 1.5 s, let's say, equals 3? Because, well, no, I don't know if that's going the right direction.
Yeah, I feel like for like the Sarah part, you could do like John plus 1.5 equals 3.
Why would you add John the 1.5 instead of Sarah?
Because you take John's you take
Oh,
John.
John plus 1.5 is Sarah because.
Yeah.
Okay,
So
okay.
X plus 1.5 equals Y or whatever.
Oh.
Okay, I think I'm seeing something. X plus 1.5 equals. X. So would it be like let's say John is X. When John moves it, X equals 5. It takes it takes him 5 hours to do it. But for her equation, it would be X plus 1.5 equals 5. Wait. Never mind. That doesn't make any sense. So then that would be 6.5. It would take her. And that doesn't make any sense either. So together it takes them 5 hours. Just with her, it takes her 6.5 hours. So how do we use those together to figure out how long he takes? Would that be a graph? Because I have like x plus y equals 5, and then y equals 6.5, let's say. Like,
Wait, how did you get this 6.5?
because for Sarah, I made Sarah y just because, but I figured together they do it 5 hours, but it takes her an hour and a half longer to do it herself, going the same distance. So she can do that distance in 6.5 hours, but together they do it in 5. So I guess the distance is kind of a...
Yeah, so with that, it takes her that much longer than John. So it says she is working alone, then it takes John. So you'd have to add that onto John's speed or time, and not the time of both of them together.
Oh, I see. Okay.
Yeah.
Man, this is a tricky question.
Yeah, I was working on it for like 20 minutes.
Oh boy. So
So how would you set up the part or an equation for both of them working together?
that's what I'm trying to figure out. I think at the basis, if we just, I think x and y can equal 5, because regardless, it's her plus him go that far. And then maybe trying to work backwards from that.
Yeah.
Oh, wait a minute. How long does it take to? Okay.
So if she takes 1.5 hours longer to move it by herself, does that mean John takes 1.5 hours less to move it himself?
Then Sarah.
Well, he's going to be slower than them working together, but he's going to be faster than her by herself. So it's somewhere between 5 hours and 6.5 hours.
Okay.
Since both of the distances are the same, can we omit that from our solving and just solve for how long it takes?
That's what I'm thinking. I'm thinking it's just, I don't think the 3 miles is really relevant to the equation, because it's all the same distance they're covering, and it's more about the time.
Okay.
Yeah, and then even when it's like, how long does it take John to move it by himself? Like, yeah, I don't think the miles is relevant.
So
Sarah takes.
Sarah and John, 5 hours. 5 hours.
Distance. gonna jump in the textbook and see if I can find anything similar.
Sarah takes 1.5 hours longer to compare at the same distance. Then it takes John.
What's that?
So Sarah plus John 5 hours. It takes 1.5 hours longer. Plus 1.
This question really doesn't make that much sense.
Yeah.
Because it's like, if they both can move it 3 miles in 5 hours, but Sarah takes 1.5 hours longer than John when he's working by himself. So that could mean John could push it in anywhere between 5.1 hours to like 32 hours, and she just takes an hour and a half longer. Like, I don't see what they're trying to get out of this question. Because, I mean, we could say it takes him 6 hours, so then Sarah takes 7.5 hours to move at the same distance.
True. So I wonder, is the answer looking for a specific answer, or is it more looking for it will take him 3 times longer when he works with Sarah? Or, you know, is it looking for that kind of thing where we're not really solving for the exact value, we're just solving for the how much more it's going to take?
I don't know, because the question is, how long does it take John to move the handcart 3 miles when doing it by himself? And the hint is it's going to take him longer than when he works with Sarah. So it's going to take him greater than 5 hours. So,
Well, there's similar problems in the book in chapter 1. But
I just don't get what it's trying to exactly get, because, like I said, it could be 5.1 hours to basically infinity.
uh-huh.
And then Sarah would just be tacked on an extra hour and a half on top of whatever it takes him.
Yeah, I think it's kind of getting at like ratios, like how much, like almost how much stronger is John compared to Sarah, and then you have to like add those two ratios together to get the 5.
Mm-hmm.
Well, I guess the question, wait, hold on.
Does this make any sense at all? So I put Sarah plus John equals 5 hours. And then Sarah is whatever John is plus 1.5 hours. And then we're trying to figure out what John is, his time is the variable here, is the thing we don't know. Yes?
Yeah.
And so I took these first two equations and I made it so that both of them gave,
Oh, we're equal to John?
yeah, both of them were equal to John, and then I made them equal to each other. And then I solved for Sarah, which was 2.25 hours. And then I plugged Sarah back into John's equation, where John is 5 hours minus 2.25 hours, and that gave me 2.75 hours.
And then you add that on to the normal 5 hours it takes them together. And that's how long it takes John.
Because it has to equal more than 5.
Yeah.
Well, I guess the question doesn't make any sense when it's actually the hint where it's like it will take him longer when he works with Sarah, because isn't he doing it faster than she is? So why is it going to take him longer?
Well, because they're pushing the cart together, so they have their strength combined when they're working together.
Oh yeah, see that's the hard part. Like, how do you divvy up their strengths?
Longer than when he works with Sarah.
I see what you're doing, and I think that's the best. Like, it makes sense, like how you did it. Just trying to figure out.
Well, we just can't figure out what. We can't even figure out what the ratio is because we can't figure out how long it takes John, because that's what they're trying to make us solve. But we don't know how long it takes him.
Mm-hmm.
We just know that Sarah takes an hour and a half longer to move it by herself than John does by himself.
Mm-hmm.
But we know that when they work together, they move it in 5 hours. So John's going to take longer than 5 hours. We just don't know how much longer than 5 hours.
Hmm.
I think there needs to be a revision on this quiz because this just doesn't make any sense. Plus these super spaces, I don't know what those are about either.
Oh, yeah, it will take blank him longer than when, what is that? Yeah, Sarah takes 1.5 blank hours long. Is that just a formatting thing?
I don't know, because it's not in just that question, because question 3, it's got those weird spaces too.
Mm-hmm.
Oh, you're right. Everything's kind of funky.
I don't know what she was doing when she typed up this quiz, but maybe it was 2:30 in the morning. She was like, "Oh, I need a quiz."
Oh man.
Because it just doesn't. I don't know.
Well, I mean, I can see the logic of what Josh did. If y'all want to move on and then maybe come back to that one, maybe get a fresh look on it. But for now, that logic's the best thing we got.
Yeah, and I just tried it out, but I got 1.75 for John.
Mm.
And I could see maybe taking that number and then adding that to 5, and then we could see
Yeah, because it's kind of what I was thinking. I don't know where it's going.
I can see that.
Yeah, but the hard part is,
or adding them together. So you just take John and then add him to John plus 1.5, and then equal both of those to 5. And then I kind of did work there, and it didn't really
Okay, I can kind of see where you're saying there.
Man.
See,
add them together, maybe. Add the two forces to give you the 5. I don't know if my math is right.
Yeah, I feel like this is one of those problems we did a couple weeks ago where you knew how much force each one was doing, so you could figure out the angles and junk, but I feel like
That doesn't seem like that's what this is asking for, though.
yeah. See, I was just saying, I wish it was as simple as the other one.
Yeah, at least that one, it like gave us everything we needed. This one just seems like
Yeah.
there's one more piece that is actually really crucial to solving this, and you're not going to get it. It's probably in one of these blanks.
Oh, yeah.
It's probably right where it says it will take blank him longer. That's probably right where our key point is that we need to know.
Yeah. So if we count, so what did you solve? So your y was how long it would take John.
Yeah.
Okay. So if it takes John, so then if you have how long it takes John, then you would add the 1.5 to get Sarah.
Uh-huh.
Yeah.
And then make that a fraction or whatever to see, it takes Sarah this long, it takes John this long, and then see what fraction those come out to. Because if it takes him this much longer, wait, what are we even asking? Oh, never mind. We're not asking. The blanks are throwing me off. I keep thinking it wants to know how much faster John.
That's what it seems like. But I don't know. I think it's just like she held down the space bar too long. Or something.
Oh, let's see.
I don't know.
That could.
But I mean, yeah, I think it does make sense to have John be the variable and then John plus 1.5. And those equal 5 because, I mean, well, I don't know. I guess it's hard to just see what the effort they're putting somehow equals 5. Like, I feel like you need to know how much force are they each exerting. I mean, is John like 2 and Sarah's 12? Like, I don't know.
I feel like I just found like the rare. I don't even know what's right. Yeah. It came out to like John is like 1.75 and then Sarah's like 3.25. Both of those added together gives you the 5, but then that doesn't really fit into anywhere else in the phone because they have to be longer than 5.
Oh, okay.
I think we just take one of those numbers and add it to 5.
So like John would be 6.75.
Yeah.
Sarah would be 8.25 kind of thing.
Yeah, because it takes them, since it takes them more to add on their extra to it. Yeah, because all it's asking is how long John takes. So we'll just add his to 5, and then that would give us, presumably, how long he would do it on his own.
Or could you like times it by the miles that they go? That won't work.
Well, yeah, see, this one, I don't feel that the miles really affects it because it's asking time, like how long does it take? So yeah, it's not even asking like who can do it faster. It's just all a time measurement.
Yeah, well, I'd say that's a good enough answer for me for now, because I have no other ideas.
Yep.
Yeah, I think that's fine. At this point, my brain's getting burned.
Yeah.
We gotta do the other quiz after this.
Are y'all ready for number 3? Do y'all feel?
Yeah.
Let's go for it.
Yeah. I need to go to bed here soon, though, because I got to get up early. We just changed our hours at work, and we start at 6 o'clock in the morning now.
Probably.
So it's not
Yeah, probably. Yeah, it's already like 8:30. We're probably gonna be at this one another while.
Yeah, it's 9:30 here. So.
Gosh.
A construction company frequently builds garages with an arch over the garage, similar to the one below. In order to build the arch, consider the entire circle, thus where the east of the circle is and the radius of the circle. Currently, they guess and check until they get the right height. Love
Oh, good. It's a great construction company.
Right. Jeez.
Information. A construction management student at BYU. I have brought this up. This is so big.
Okay, if the garage is 18 feet wide, and the owner wants the arch to have a height of 12 inches, what is the radius of the circle that is necessary to cut the arch? Okay. So are we like solving for these two triangles is kind of what it's looking like?
It says in question 3, write a system of equations with two unknowns. So I'm not 100% sure what that means.
Is the number C, is that a separate question or is that in regards to this problem?
It's in regards to this one because we have A, B, and C.
And R and Y are variables in the sketch.
Building and solving a system of nonlinear equations. Okay.
You going to Utah tonight? I'm driving.
Like I felt like we haven't done any of this. System of nonlinear.
Ooh. Okay.
Oh wait, okay, hold on. So the radius is equal to y plus 12.
Yes.
Or
R equals Y plus 12 inches.
oh,
Which is
yes.
1 foot.
And then what? R equals Y squared, or wait, R equals Y squared plus 9 squared, or R squared.
Since everything's in feet, I'm just gonna switch that 12 to 1.
To 1. Okay. Sorry, what did you say? R was equal to y squared, or?
You just use the Pythagorean theorem, right?
Oh.
So you can do like r squared equals 9 squared plus y squared.
Oh, okay. I see. To solve for the triangle.
Yeah, so you get the y by using both equations.
So if the R is 2 equals 9 squared plus 1 squared, because y equals 1 if we're using it in feet.
Like I said, and then I guess the 9 foot would just be 0.75 squared. Or wait, no, it's feet, not inches. Like what? That picture is not proportionate.
So if we did that, R equals 9 squared plus y squared, that would give us, because 1 would plug in for y, since that's 1 foot, 9 would be already in feet. And then squaring that out would be 9.1.
Mhm.
Well, when it says write a system of 2 equations with 2 unknowns, we've got the R. How would you write it out for y? Y equals R minus a foot? Then I feel like that's just like the same. Yeah, I tried working it. I got r equals -8, and that doesn't even make any sense.
Mm.
Whoa. R squared squared R squared R is y plus 1. Substitute that. 21. I got y equals 40 feet.
Mm.
Which then would mean r is 41 feet. But that doesn't really make sense either.
Yeah. Yeah, see, I got, even if y was 8 feet, that would make r 12 feet, which doesn't make sense because if r's the radius, which is 12 feet, it doesn't equal, or sorry, that it doesn't make any sense. Huh.
What methods are you guys using to solve this?
I tried to do r equals y plus 1 foot, and then I tried to do the Pythagorean theorem to kind of solve for what r should be, but that, for me, that's not coming out to make any numbers that make sense. And I've worked it like 4 times.
Yeah.
But it says it can be answered through a system of nonlinear equations. I mean, I guess that's how it wants us to do it, but I just...
System of nonlinear equation.
Well, I guess it's asking us to make an equation with r as the variable and y as the variable. And I'm not sure what to do for the y variable.
Let me show you what I got just to see if it makes any sense at all. So I have the thing here, and I said, what did I say? I said r equals y plus 1.
Yeah, could you hold it a little closer? Sorry, it's kind of blurry.
Yeah. And then using Pythagorean theorem, I said 9 squared plus y squared equals r squared.
Mm-hmm.
And then I plugged that in for r.
Oh.
And then factored that out and got y squared plus 2y plus 1. And then over here we have y squared plus 81. And then the y squareds cancel out if you subtract. And then you're left with 2y equals 80, and then y equals 40. But looking at the picture, it doesn't really make sense. Unless it's like specifically not like drawn to proportion or whatever.
Yeah, I like the direction you went. In fact, I tried to go that way with the Pythagorean, but let me do the substitution that you were doing with what I was trying to do and see if that gets anywhere. Because, yeah, I don't think it'd be 40 feet given the structure's only 18 feet wide.
Yeah, that doesn't make sense at all.
Yeah, so you got the r equals y plus 1, and that was your equation for r, right?
Yeah.
Okay. I'm going to try to do the r squared equals 9 squared plus y squared. And I isolated y in that. And I'm going to try and plug the first r into that r and see if it gives anything that makes maybe more sense. Okay, never mind. If I try to plug it in like that, then my y's just cancel out. Yeah, because see, I tried to do I had the y, hold on. I had the y, r equals y plus 1, and then the Pythagorean, which gave me r equals 9 plus y, if I did that correctly. And then I tried to plug in this back for r, but that just doesn't, I guess that substitution didn't make sense. I thought maybe it'd give something different, but I mean, I think we're all on the right path from getting two of the variables like it wants us to. It's just trying to figure out how it wants us to put them.
Yeah.
Well, it said if they can plug and chug numbers, I think we can too, because 9 squared plus y squared should equal r squared, but r squared should equal y plus the 12 inches. So, right? If those two are equal. This makes sense that r squared should equal 9 squared y squared because of the Pythagorean theorem, but at the same time, since that's the radius, r squared should also equal the distance of y plus 1 foot. So those should equal each other. In theory.
Let's try that out.
Oh, wait a minute. Yeah, I tried to work it out one way and then got y squared minus y plus 80 as a thing to factor, but I
got that too. But
Mhm.
that doesn't make any sense to factor.
yeah.
Like the way that makes most sense to me is like plugging r equals y plus 1, and then 9 squared plus y squared equals r squared. But then, I mean, like that method makes most sense to me, but the answer I got doesn't make sense at all.
Yeah, that's what I'm finding is like I feel like that's the variables given the information. But I mean, well, it says solve them using substitution or elimination. I feel like substituting them isn't getting us where we need to go.
But essentially, wouldn't you get the same answer if you used either one?
Right, you should, but I don't know why we're getting outlandish answers. I'm going to try to do it a different way. Substituting the y plus 1 into the r squared. Because I feel like those two equations are maybe on the right path, but okay, I see where you got the 40 from, but that still doesn't make any sense with the problem.
I just tried, what's it called? Oh, never mind. I essentially did the same thing there, I think. Yeah, I just did the same thing there. Well, if actually wait. What do we have? Yeah, solving using substitution and solving using elimination gets the same answer.
Bless you. I mean, geez, at this point, I'm like, we have those equations. These are the answers we get. Our methods are good. Our answer is bad.
Mhm.
I'm honestly like I need to get going soon. But
Yeah.
Yeah.
Here. I mean, if y'all want, I mean, I'm fine with. Those are the equations we have. We made a system of equations with two unknowns and solved them substitution or elimination, and we're not getting the correct answer, but I know we'll get credit for at least going through the process. We just won't get full credit for not having the correct answer.
yeah, I'm fine with that, honestly, at this point.
Yeah.
I can sleep with that.
Yeah, it's already 10 for me, so.
Yeah, that sounds fine. Sorry it took so long.
That's all right.
Who wants to submit it for this week? I don't know how confident I am in all my chicken scratch.
I don't know if I have absolutely everything, and it's like all scattered on 5 different pieces of paper right now. So.
See. We could all pick a different problem and write it out, and I'll email it to one person. So maybe all of us did one of them, or whatever you had for.
Let me see what I do have.
Yeah, I don't have problem 1 written down at all.
I think that's the one I don't have either.
I have one. All of it worked out.
Okay, I can email you number 2. Or no,
Okay.
not number 2. Oh, 1 is the one I have worked out. Never mind. So I don't have. One second. Oh, there's number 2. I don't know if I got number 2. So
Yeah,
I do have
one I
one.
probably understood the least.
Which one?
Number 2, I
No.
couldn't even make heads or tails of it, so y'all had much better explanations than I did.
But then Josiah and I we got different answers, so I don't know.
For number 2. Or,
Yeah, for number 2.
yeah.
I don't know if y'all want to both send them to me and I can look them over or flip a coin.
Just submit both of them. Be like, hey, this is the work we did.
Okay.
Yeah, I'll send you a picture of an other thing.
Well, in our reality, I'm sure she would be like, "Hey, I mean, this is what we came together as a group, and we solved 2 different ways because it was a difficult problem."
Yeah.
But, do y'all have my email? Or text it to me, or I mean, however works.
Yeah.
Do you have ours?
Yes.
Could you just like email like a really quick go ahead and send them here and we can like reply to that email with our pictures?
Yeah, I'll go ahead and do that.
Okay.
If y'all don't get an email like before, I'm gonna send it right now. But if y'all don't get an email like by later tonight or something, then let me know because that'll mean it didn't go through.
Okay.
But I'll send it to the emails that I invite you to this chat with.
Okay. Be right.
Okay. Awesome. Well, thanks, guys. I'll go ahead and get the broadcast off so I can get it submitted, and then we'll do the rest of it tonight.
Okay, awesome.
Sounds good.